All right, welcome to the practice quiz for sections 413 through 418. That's Unit 4, 13 through 18. In the second part of Unit 4, we saw a different kind of growth and decay model, and it's this one right here, where this number in front is the starting point. That's how many there are in the beginning, and then that number right there represents the change. The model for growth and decay with E in it has to do with how things are changing in an instant in time. So the population of a town doesn't change like at the end of the month or at the end of the year or at the end of the quarter of the year. It changes all the time. New people are coming to the town and new people are leaving the town, whether it's by, just moving around or whatever. So that's what this is used for. So populations of people, populations of bacteria, that kind of thing. This is the better preferred model for that. In 2010, it says there were 8.75, and that's in thousands. So I want you to write out 8,750. That would be the number of people. And then, of course, that right there is the rate. And it looks like a penny, so it's 1% was the growth rate. Now, when did it reach 20,000? So I'm going to set up the equation right here. 8,750 e to the 0.01 t is equal to 20,000. So I changed this to 8,750 to make it match the 20,000 over here, so the decimal points are the same. If I didn't, then I would have put 20 there. And it'll all work out because my first step is to divide over the 8,750. So e to the 0.01 t is equal to. Now, when you divide that, you get a kind of a crazy decimal. Here, let's just look at it. And let's see. We got 20,000, 1, 2, 3, divided by 8,750. And so I said crazy decimals, but if you do the whole math trick, convert back to a fraction, you get 16/7, which isn't that bad. So 16/7. I gotta move that away quick. 16/7 when you move it back to a fraction. All right, so now we're going to bay it up. I'll draw a line there to show that I'm going over here. And so it's log base e, which so I write natural log of the fraction 16/7 is equal to 0.01t. And like I like to say, there's multiplication in them thar hills, so I'm going to divide over that decimal. Let me find my red pen here. There it is. So I'm going to divide over, that's kind of more pink, isn't it? That's okay. So that cancels out. T is by itself, and that is the exact answer. So t is exactly equal to the natural log of 16/7 over 0.01. I want to see that on your paper, and because I want to see the exact answer, and I also want to see then the approximate answer. So we're going to type this into the calculator. It's natural log of 16 divided by 7, close the parentheses, divided by 0.01 equals, so 82.667 years. We'll do 668 years. All right. So that means in 82 years into the future, so 82 years into the future will be 2092. So 2092 is the year which it'll hit the 20,000. All right, now we're just going to solve some equations. Divide by 4, get rid of that division, 22. Then I just got to log it, right? Switch it up. The base is what? Base 10, right? So it's log base 10. Okay, I don't need that of 22 because that means log base 10 is equal to x. So I want to see that answer. That's the exact answer. Then you can give me the approximation by typing it in. I don't need to do any fancy thing. It's just log base 10. And 342, 1.342. All right, the next one here, I'm going to make it in log form. So it's log base e. Okay, so it's natural log 100 is equal to x minus 2. And then I'm just going to add the 2 over. So don't make the mistake of adding those together because you can't. It's natural log of 100. So when I say of 100, I'll put that parentheses around it. So probably should have put it there. It's natural log of 100, and then plus 2 is equal to x. So again, that's the exact answer. And now we're going to type it into the calculator and get a decimal approximation. So natural log of 100, close the parentheses, very important, plus 2. 3 decimal places, 605. So 6.605. Okay, so that's the first page. This one here, you almost don't even need to do anything because it's 10 and then powers of 10 over here. So there's actually 2 ways you could look at this. You could say 10 to the x plus 3 is equal to 10 to the 6th power. So a million is 6 zeros. So then those have to be the same with each other. So x plus 3 has to be 6, therefore x is 3. That's one way to look at it, or you can do the log thing if you want to. So it's log base 10, so it'll be log of a million. Put some commas in there so I don't get too few or too many zeros, is equal to the exponent, x plus 3. When you type that in the calculator, you will get 6, and then x plus 3, and then of course x is 3. So you can look at it either way. Now this one here is going to have a decimal answer to it, just because the numbers are in it. They don't match up. Like that matched to that really nice, so it had a nice answer. Okay, so then I guess we'll just do the log base 7 of 285 is equal to 3. Log base 7 of 285 is equal to 3x. Okay, I'm going to divide over the 3. Again, like I said, there's multiplication in them Nar Hills. So it's 3 times x, so I got to divide the 3 over. So this is the exact answer, log base 7 of 285 over 3, which is approximately equal to math, up arrow, log base 7 of 285, push myself through, divided by 3, and it's not quite even 1, 0.968. All right. So the problem here, we're talking about mold growing, and we just want to know when it fills the wall. So when does it hit 80? So you go across here, and you go down, and I said about 6.6. 6.6 months. So we'll label our answer. So that's all you're doing with that one. Okay, so there's infinitely many answers to number 7. You just need to pick one that you want. So this one starts at 18. Starts at 18. I just picked that point as 18, and it's going to grow like that. Okay, so I need to pick something that's lower than it and make it grow faster than it. So I'll just say my population is lower, anything lower than 18,000, because that 18 means 18,000, so I'll just pick 10,000. And then E, and then I just need a bigger growth rate. Well, my answer key, I did 5% to the times N. N is the number of years. So the book likes to keep you hopping. Sometimes T is the number of years or whatever. This time it's N. So all that stuff. All right, so that's an answer for that. All right, so now we're going to figure out which one's which. Now it's important that you understand what's going on here. The lowest one has the highest. The lowest one has the highest base, because it takes longer for it to grow up. So that's related to the base, the exponent, the answer, and all that kind of stuff. So that means this done down here is the base 10. So this is the s of x, and then this one's the t of x. All right, now you're just evaluating at 250. So we go here, and we go there. 250 for t is about 8. Oops. About 8. See? 8. And then this one's a little bigger than 2. The paper got caught. About 2.4. All right, that's it. 10 minutes. Good luck on the quiz.